Hello children, welcome back to Science Capsule, a perfect self-learning tool. We are learning the chapter carbon and its compounds, and for your information, so far we have completed 7 episodes. If you have not watched those episodes, then I'll provide the link in the I button as well as you will find in the description too. So this is our 8th episode, and in this episode we are going to learn the chemical properties of carbon compounds. As we know that millions and millions of carbon compounds exist in the nature, so knowing about chemical properties is very important, isn't it? So as far as class 10th is concerned, we have to study 4 important chemical properties. They are combustion, oxidation, adhesion and substitution reaction. Let us take all these with some examples and let us understand all those chemical properties in detail. So this video is going to be very informative, so watch till the end of this video. Dear students, if not subscribe this channel, subscribe this channel and press bell icon so that you won't miss any of my future uploads. So let us start today's episode. So let us understand various chemical properties of carbon compounds. So firstly, talk about the combustion process. Dear students, carbon can combine with oxygen and produce carbon dioxide, heat and light. This type of chemical reaction is called combustion reactions. Dear students, here carbon and all the allotropic form of carbon such as graphite, diamond, fullerenes all can combine with oxygen and produce carbon dioxide, heat and light. So altogether we can say that carbon and its allotropic form can undergo combustion process. Let us take some of the examples. Here carbon combines with oxygen and produces carbon dioxide, heat and light. Likewise, in the second reaction you can see methane, the lower member of a hydrocarbon, combines with oxygen, produces carbon dioxide, heat and light. The third example is ethanol, which undergoes combustion process and produces carbon dioxide, water, heat and light. If you see all the 3 equations, then you will find carbon dioxide, heat and light are common. So we can understand that the chemical reaction which gives carbon dioxide, heat and light are called combustion reaction. Got it? Dear students, in the previous episodes we have learned about saturated hydrocarbon and unsaturated hydrocarbon. We can differentiate saturated and unsaturated hydrocarbon on the basis of combustion. How can we do this? Dear students, as a result of combustion, heat and light will be produced. We can understand that flame will be produced, isn't it? If the flame is sooty flame, then we can say that the hydrocarbon is unsaturated hydrocarbon. We can expect at least one double bond or a triple bond. So we can understand that if we burn any carbon compound and the carbon compound produces a smoky flame or a sooty flame, we can see how can we identify. If we place any object over the flame, then the object will get blackened. So black tiny deposits, that is carbon deposits, you can see. So such tiny carbon particles we call it as a sooty, or it produces a smoky flame. So the carbon compounds which burns with the smoky flame will be unsaturated hydrocarbon, and the hydrocarbon which burns with a clean flame, we call it as a saturated hydrocarbon. You are very much familiar with the gas stove which you use in our home, isn't it? So it burns with a blue flame which gives a clean flame. If you keep any vessel and you cook food, then you won't see any black spot under the vessel, which means the hydrocarbon which we use in our gas cylinder is a saturated hydrocarbon. That is why they won't produce any smoke. The holes on the burners is just to ensure for sufficient oxygen supply. If the holes are blocked, then insufficient oxygen will be available for the gas to burn, and in that case the fuel burns with a sooty flame. That is why sometimes after a long time the vessels may get blackened. This is due to the fact that the holes on the burners may get blocked. If you remove the blockage, then once again the fuel burns with a clean flame. Got it? Let us learn the second property of carbon compounds, that is oxidation reaction. Dear students, we have already studied about oxidation reaction in the first chapter, where the oxygen combines with any substance, then oxides are produced. This we have already studied. So oxidation is a process in which addition of oxygen takes place, which we have already studied. Here, carbon compounds can undergo oxidation process. Let us understand the oxidation process by an example. Here, alcohol, ethyl alcohol, that is ethanol, undergo oxidation in presence of alkaline KMnO4, that is potassium permanganate, or in presence of acidified potassium dichromate. Either one of this you can use. As a result of this, on the product side you can see carboxylic acid, that is ethanoic acid, is produced. This reaction is called oxidation reaction. So in examination, question may be asked in this way: how can you convert an alcohol into carboxylic acid? The answer is very simple. Oxidation of alcohol gives you carboxylic acid. So here you see the functional group. On the left hand side, that is on the reactant side, alcohol is the reactant, and under oxidation of this alcohol we get, on the product side we find carboxylic acid as a functional group. So you keep in mind that oxidation of alcohol leads to give carboxylic acid. Here in this reaction, alkaline KMnO4 or acidified potassium dichromate acts as an oxidizing agent. Got it? So that's all we have to see in the oxidation process. Got it? Now let us see the third chemical property of carbon compounds, that is adhesion reaction. Let us understand the adhesion reaction with an example. Here you see on the screen an unsaturated hydrocarbon, that is ethene, is converted into saturated hydrocarbon, that is ethane, in presence of a suitable catalyst. Here in this case nickel has been taken as catalyst. This reaction is called adhesion reaction. Here the main role of catalyst is to speed up a chemical reaction. In any chemical reaction, the role of catalyst is to increase or to speed up the chemical reaction. Normally the unsaturated hydrocarbon and hydrogen will not combine. It needs a suitable environment. That environment is provided by the catalyst, so the chemical reaction can occur. Got it? This reaction is also known as the hydrogenation reaction. Why? Because you see on the product side 2 atoms of hydrogen are added, so we call it as hydrogenation reaction. This type of hydrogenation takes place in converting unsaturated vegetable oil into saturated vegetable oil. So this is all about adhesion reaction. In the examination, questions on this topic may be asked. How the question would be: how can you convert an unsaturated hydrocarbon into saturated hydrocarbon? Answer is very simple. It is by the process of adhesion reaction. So this is all about adhesion reaction. Now let us see the fourth property, that is substitution reaction. Let us understand this substitution reaction with an example. Students, you should know that the saturated hydrocarbons are unreactive. This is due to the fact that the valency is completely filled and they do not show any reactivity and inert in presence of various reagents, but they show somewhat reactivity in presence of sunlight. Chlorine, bromine are some of the species which can react with saturated hydrocarbon and replaces hydrogen from the hydrocarbon. So here chlorine, bromine, those elements substitutes the hydrogen from the hydrocarbon, so the reaction is called substitution reaction. Dear students, here the substitution reaction facilitates for the existence of a large number of carbon compounds, which we call it as versatile nature of carbon. In case of a higher number of the hydrocarbon series, a large number of carbon compounds it can form. So this is all about substitution reaction. So I hope you found this video useful. If so, hit the like button and share as much as possible to your friends. So that's all we have in today's episode. See you in the next. Bye bye.